So now that we have talked about how to find a greatest common factor and a set of expressions, let's begin to talk about what it means to factor out the greatest common factor from a polynomial. Essentially what we're doing when we do this is we are doing a reverse distribution. So back in Unit 2, when we learned how to distribute in values into like a linear equation, the greatest common factor, essentially we are doing the reverse of that. So without further ado, let's just take a look at example 1. So we have 2a squared plus 4a. So we have to first identify the greatest common factor from that polynomial. And here I can see that we have a 2 and a 4, and I can divide both 2 and 4 by 2. So I'm going to go ahead and put that there. And then we have an a squared and an a. And recall from the previous section when we were finding the greatest common factor of variables with exponents, we wanted to take out the variable with the smallest exponent. So in this case, the smallest exponent is just a to the first power, or in other words, a. So the greatest common factor is 2a. And now to actually factor that out of the polynomial, it's going to be very similar to what we did in the last section. So we're going to bring out 2a in the front, and then we're going to divide 2a by every term within the polynomial. So this first term here, we have 2a squared. So we're going to take 2a squared and divide it by 2a. And then here, we're going to bring that addition sign down over here. And then we're going to add 4a all divided by 2a. And when we do that, we get 2a times 2a squared divided by 2a becomes just a. And then here we have 4a divided by 2a. The a's cancel, and 4 divided by 2 is just 2, so we get a plus 2. And that's your final answer. Alrighty, so try example number 2 on your own, doing the same exact steps we did before. And assuming you have given it a go, let's go through this together. So the greatest common factor in this case, we aren't going to have a coefficient out in front like we did in the first example, because here the second term, it doesn't have a coefficient. I mean, technically it has a coefficient of 1, but we can't, it won't really help us to factor out a 1. So in this case, we aren't going to have a coefficient, but we are going to factor out a variable. And in this case, we're going to factor out a k. And when we do that, we get k times 10k divided by k plus k cubed divided by k. And simplifying this out, we get k times 10k divided by k. Those k's cancel, so we get k times 10 plus k cubed divided by k, using our exponent rules, is k squared. And that's your final answer. Looking at example number 3, we have negative 24n squared plus 8n. So looking here, looking at 24 and 8, I can identify that both of these terms are divisible by 8. So I'm going to go ahead and write that here. And both of these terms have an n, so I'm going to go ahead and also factor that out. And when we do that, we get 8n times negative 24n squared divided by 8n plus 8n divided by 8n. And when we simplify this out, we get 8n times negative 24 divided by 8 is negative 3. And then n squared divided by n just becomes n. And then we're going to add this 8n and 8n. They cancel, so we just get 3n plus 1. Alrighty, and for our last example, I encourage you to pause the video and try this on your own. Now let's go through this together. So the greatest common factor, when I look at the coefficients here, I can see that all these coefficients are divisible by 6. So I'm going to go ahead and write that out. And then all these terms have a variable, which is v, and the smallest power is 1, so I'm just going to divide all these out by 6v specifically. And when I do that, I'm going to write 6v out in front here. And then we got to divide 6v by all 4 terms. So we're going to have negative 36v to the 4th divided by 6v plus 6v cubed divided by 6v minus 6v squared divided by 6v minus 12v divided by 6v. And once we simplify all this out, we're going to get 6v times negative 6v cubed plus v squared minus v and then minus 2. And that's your final answer.